Hello everyone, let's proceed for solving some of the numerical for the convolutional encoders. How to proceed with that in numerical part, let's see it. Let's assume that there is one example given to you to solve it either by using, let's say, the state diagram, code tree, or the tree diagram and the trellis diagram. Earlier we have seen how to proceed for it. This is what one of the example. Let's say the for the given convolutional encoder, draw the state diagram, code tree as well as the trellis diagram. If the diagram is like this, the conventions instead of, let's say, uh, the diagram with the first bit stored in the S1, someone may give it like X, Y, Z or S1, S2, S3. So don't get means disturb over here. What exactly these? So these blocks are reserved for the flip-flop or the memory elements. So input will be accepted from the left side. S1, S2, S3. When we XOR it, it will give us the first output bit, that is V1. Similarly, when S1 and S3 are XOR, it will give the second output bit, that is V2. So by the shuffling from, let's say, V1 to V2, we will get, let's say, the output, combined output. So in short, this is nothing but 1 by 2 encoder circuit. Why it is 1? Because every time it will just accept single input bit and two output bits, V1 and V2. If we want to comment, let's say, the constant length, so active flip-flops will be S2 and S3, and the total constant length for this particular thing, it will be what? 2 plus 1 means that is 3. So actually for this input bit, total 3 shifts will occur to reach at the output. So that's why k is equal to 3. So it means it is nothing but the constant length equal to 3. So once we analyze this, then we can prepare the simplified, let's say, the state table in this manner. So input bit S1, S2, S3, let's start from 000 to 111. Ultimately, this is like when the 00 input is there, either the let's say S2 and S3 will have the status 00. So input bit will be either 0 or 1. So that's why with this concept, it is simply been treated like, we can say the next state is 0 1, next is 1 0, and finally 1 1. So for each case 0 1 0 1 0 1 has to be repeated. So these output bits will be prepared based on the XOR things, like V1 is nothing but obtained from the XOR operation of S1, S2, S3, and V2 is obtained from the XOR operation of S1 and S3. So this is what the result for this V1 V2 column. Now the next column, this is slightly simplified over here in this particular lecture. So NS is nothing but the next state, PS is the present state. Input bit will be accepted obviously in the S1. So that is what input bit, every time it will be accepted firstly in the S1, then further shifts will be done, but firstly it will be in the S1 itself. So that is what done over here. Now I will just provide here the hint how to prepare this next state without giving too much stress on the brain. So here let's see, when the S1 is shifted to S2, then S2 will be shifted to S3. It means obviously whatever the status we are having for S1, S2, the same status will be shifted after, let's say, first shift to the next. So it means this column of input bit and present state, so first stage, let's say S1, S2, can be written as a S2, S3 over here as a next state. So this is what the simplified, you can say, the structure to prepare this particular state table. So this is what our state table. How to prepare it? It is very simple. To prepare V1, use the equations, as well as to prepare V2, use the equation. To prepare S2, S1 to S3, already we have seen it. How to prepare it? Start from, let's say, 0 0 0 0 over here, 0 1 0 0 again 1, So 0 1 0 1 input bit will be either 0 or 1. So accordingly 000 to 111, that is what the concept over here. But to prepare next step, this is the easiest way. Copy these first two columns as it is as a next step. So once it is done, means once the state table is prepared, this is what the preparation of the state diagram, which will indicate like 00 to 10 transaction, that is for the input bit 1 since it is discontinuous line, and the figure which we are going to write above the line, that is indicated as a output bits. Okay, so that is what the, in short we can say, output bits everywhere we can observe with these digits on the line, but these lines are having a special significance. So once we done with all this assessment, then just unfold this state diagram to get the Trellis diagram. Now in some of the articles you may observe that this 00 as a, then 01 as a b, 10 as a c, and 11 as a d. So it doesn't affect to the result too much. Only the convention to write 00 as a, that is what matters. Otherwise rest of the things are same. Now this is what the Trellis diagram for the same example. So by writing it in a simplified way, this is how it will become. So here 00 10 01 and 11. So based on the state of the encoder, these four states are just mentioned over here because the only two flip-flops will decide the state of the encoder apart from three. Okay, first flip-flop is simply to take the input bits. So once we prepare this state uh, diagram unfolding, in short it is called as a Trellis diagram, so TD. So once the Trellis diagram is done, so the next start is next task is, let's say, the 101. So if the input bit is 101 for the encoder, so 1, it means starting from 00 1 input bit 1, it indicates that we are tracking for the discontinuous line. So 1 1 will be the output, so that is what the corresponding output. Next is for the input bit 0, follow the continuous line, so output will be 1 0. Again next it is 1. So since from this again it is 1, it means we are having the discontinuous line to be followed and write down the corresponding output bit, so it will be 0 0. So this will be written over here. Now at this point further input bits are not specified, so from this point we need to track which is the shortest path to reach at the 0 0. So let's say there are certain paths like this can be further reached, but this is quite a longer one to reach at the 0 0. Now we need to follow the shortest path. So this is what the shortest path from this particular state means, from 1 0. Okay, so uh, this is what just prepared over here, that this path will be followed, so corresponding output bits will be 1 0. After this again there are further paths, means this will reach over here, then further, means to reach to the 0 0 it will take two steps, but we need to just follow the shortest, so this will be the shortest. So that's why from this point we reach to the 0 0 with this particular path, so 1 1 will be the output bits. So this is how, this is the correct answer we can say for 101. So here the two zeros are being appended virtually. If we don't append it on the Trellis diagram, we need to show that how it is done. So this is what the path for this particular, we can say, the Trellis diagram. So this is what the path tracked for the input 10100. So if you just track it, let's say for the 1011, for the 1011 input, so it will be 1, then 0, then again it is 1. So just check over here. Now the next it is 1. So it means this is sorry, this is what 1. Okay, 1 0 1 and again 1 means 0 1. So 1 1 1 0 and 0 0, after that it should give me the output as a 0 1. So if the input is, let's say, 1 0 1 1, then the output will be like 1 1 1 0 0 0 and 0 1. So this is what the simplified technique to track out for the different input bits, how to track the continuous, discontinuous, continuous, discontinuous path based on the input bits. Okay. Thank you everyone. This is what the lecture on the trellis diagram.